Hi everyone, I'm Moses. I'm currently a graduate student in the CS department, and today I'm going to be talking about ModelScopeT2V. ModelScopeT2V is a text-to-video model that basically takes in an input or a text input or prompt and generates a video based on this input that is given, a video corresponding to that. And how it does that, it passes this test through a system or a diffusion model, and that is through the main means it's able to generate the corresponding video. And so today I'm going to be going through the details of that and how this works. With the rapid development of artificial intelligence, you have seen the rise of various models that are used for the generation of media, and this kind of media include video, audio, and also like images. And you have like they basically taking text inputs and able to generate, through a diffusion model or through various vision transformer model, are able to generate these images or this kind of media corresponding to the designated inputs. But these models that we have seen so far, even in class, we realize that text to image generation is tends to be one of the most developed, and because there's a significant amount of open source code base available for those kind of work. So these researchers are able to access the background diffusion models or methods that can be used to develop these text to image models. But the problem is that for text to video generation, there isn't that much available open source code base, and as a result, there is no significant research and progress happening in that space, and that is a challenge that ModelScopeT2V is trying to attempt or trying to solve this challenge, and it does this by presenting a new trainable baseline for the video generation for its system. So this lack of available code base with regards to methods that can be used to develop the text to video generations presents difficulty in the training for these kind of models, and as a result, the videos that have been generated so far from previous work, they exhibit suboptimal fidelity and also motion discontinuity. And so ModelScopeT2V aims to solve or help solve this problem, by using two main approaches. And first is its architecture. It uses like a latent diffusion model that employs a spatial temporal block to model temporal dependencies. And then in its pre-training, it uses both the image test and also the video test data set. So it uses both of them in its the development of the videos through the diffusion model. And this helps to enhance the model's semantic richness. And that is an improvement compared to existing work in the text to video generation. So as you can see in this diagram here, it illustrates the overall architecture for the ModelScopeT2V, and you can see here that we have the images, the videos that are inputted as for training, and we have the VQ GAN, which is basically used for encoding and decoding, and you have the latent space. And in the latent space, we have a diffusion model, and it's mostly a stable diffusion model that is employed for this tool, and also in this paper. The video diffusion model that is used here in the model, it employs a unit architecture, which consists of four key building blocks: the initial block, the initial block, where the downsampling block, the spatial temporal block, and the upsampling block. And so the initial block basically projects the inputs into the embedding space, whilst the downsampling and upsampling blocks spatially downsample and upsample the feature maps. And after that, we have the spatial temporal block, which plays a crucial role in capturing the complex spatial and temporal dependencies in the latent space. And as a result, it's able to enhance the quality of the video synthesis. So in this slide, you're going to see some outputs from the model given prompts that were entered. The first is the prompt that describes I made a flight over a mountain range with a river. And this is a summer morning. The second is a boat in the river, and the third is a dog running in the park. So let's see how it turned out. You can see it was pretty well done in terms of the shadows and the colors. The boat in the river too had very good rendering, and also the reflectance and the reflection zone was pretty good. And the dog in the park, we can see there were some changes in the face of the dog as done by, but overall it was it was pretty good. Yeah. I think a major limitation that I observed was that when the number of frames were increased, the quality of the video decreased significantly. The initial frames in the original video was 16, but when I increased it to like 64, the video quality diminished drastically. And you can see over here for the corresponding videos from the previous one, it was like pretty, it didn't turn out very well. So overall, there's room for improvement, but I think this is a step in the right direction, and it has a lot of promise